guys, Mr. Mises here, and I'm looking at trig derivatives. So over here, I have all of the trig derivatives that you're going to need to know in this class. Derivative sine, derivative cosine, derivative tangent, derivative cotangent, derivative secant, and derivative cosecant. If you don't know these yet, here they are. Learn them. I'm not going to go through all of them. I am going to go over a few examples. So here we go. Let's find the derivative of sine over cosine. Now you all know that's tangent, so we're basically proving or deriving that formula. So we're going to use the quotient rule that we just talked about. Y prime equals low d high, the derivative sine is cosine, minus high sine. D low, the derivative cosine is over here, it's negative sine. Negative sine. Square the bottom, cosine squared, and away we go! So what do we get when we simplify this? Cosine squared plus sine squared. Oh, I feel an identity coming on. Okay, cosine squared plus sine squared is 1 over cosine squared, which we get secant squared x. So there we go, how we got that derivative. Alright, so let's take a look at another example here. We've got f of x equals 2x cosine x. So the derivative, notice here, I have 2x and cosine x. These are two different functions. So they're multiplied together. We are going to use the product rule. So derivative of the first is 2 times cosine x plus 2x times the derivative of cosine x, which is negative sine x. Boom. Alright? Done. Let's do one more example. Be right back. Boom. Alright, here I come again for this last example on the trig derivative. So here I want to find the equation of a line that is tangent to the graph of y equals sine theta over theta. We're going to consider theta kind of our x value here when theta is equal to pi. Okay, so I love pi. A lot of you know that. Here we go. So the first thing we knew is we need to find the derivative, right? Actually, you know what? Before we do that, we have theta equals pi. We need to find the y value when theta is pi. So the y value when theta is pi, I'm going to go and plug in pi in my formula here, my function. Sine of pi is 0, so this is just going to give me 0. So I'm looking at the point 0. I'm looking at the point pi comma 0. All right, I'll remember that when I get to it. So we need the derivative. So low, remember quotient rule here. Low d high cosine of theta is the derivative of sine, minus high d low. The derivative of theta is just going to be 1 because we're going to consider it like x. Square the bottom and away we go. Alright, at this point we need to plug in pi to figure out what our slope is. So our slope at pi is going to be pi times cosine of pi minus sine of pi over pi squared. Oh my god, I'm getting hungry. There's so much pi. Okay, the cosine of pi is negative 1, right? So we're going to have negative pi. That's after we've eaten too much pi, right? Minus 0 over pi squared. Pi cancels one of those, and we get negative 1 over pi. So there's our slope. So let's go and make our equation. Our equation is going to be y minus y1, because I said so, that's why. y1 is 0 equals m, negative 1 over pi, x minus x1, which is pi. And that is an equation. That's a good enough equation for us. That's the equation. See you later. I'm going to go get some pi.